Okay, so now we're going to go over Tactics Box 3.2, which is homework problem number 2. In this one, we're finding the acceleration vector. Now, I want to just point out that the acceleration vector, as we recall, what we were learning in Chapter 2 is acceleration is defined as the change in velocity over the change in time. Change in velocity is the same as v final minus v initial, right? Now we were doing this with numbers and we were doing it algebraically, but all we're doing in this chapter is solving the same problem, but we're doing it this time with geometry. So these are all vectors now. So if I had a situation where I had here's 3 points that we're traveling. So here's my first velocity vector, which I call v initial. Here's my second velocity vector, which I call v final. And by the way, just for the sake of discussion, the resultant velocity would be like this. I'll call this v total. Okay? But what is the acceleration? The acceleration is not, v total is vi plus vf, but acceleration is a subtraction. So I need to subtract these two vectors. So no problem. How do I do the subtraction? We just learned that. So if I start with vi like this is my v initial. Now how do I subtract this? Well, first thing I have to do is flip it. So I flip it. I'm just eyeballing this, so if I'm not perfect, give a little grace here. So I flip vf. So this is minus vf right there. Okay. Now because acceleration is equal to the difference of these two, now I can draw the resultant vector, and this is acceleration. I should be using lowercase for this, not uppercase. Okay, so my acceleration vector is this one, which is vi minus, oh goodness, I did that incorrectly, didn't I? I just did vi minus vf, which is not correct. Let me try that again. I need vf minus vi, so I start with vf, which is this one. Now I'm going to reverse vi. So I take that one, I reverse it. I can put it either here or here, either one. So I'll just put it here. This is minus vi. Now what's my resultant vector? This is my resultant vector, which is the acceleration. Okay. So let's come back and look at the tactics box. That's kind of what they were showing here again. They maybe described it in a little more confusing way. So you have these two vectors. They're saying first start by drawing your first vector, your vi, v initial, or v final, I'm sorry. So start by drawing v final. And now take v initial, just like we did in the last one, flip it because we need the negative of it, and put it there. And now they're recommending that you draw this vector here, which is really kind of confusing. But basically, this becomes your acceleration. This is your acceleration right there, what they were drawing. Okay? Because this is how much your velocity changed. What I drew here was the resultant velocity. What they're drawing here is delta V. And remember, what is delta V? Delta V equals V final minus V initial. So the way they label it here might have been a little confusing, but by basically drawing the difference here, subtracting the two, that is acceleration. Okay, so let's come back to this and maybe let's do another example. Let's say I have my position is something like this. Well, that's pretty much trying to get something different. Okay, I'll just do that. All right, so this is V initial. This is V final. All right, so I want to look for two things. Let's look for the resulting velocity, in other words, the total velocity, which of course is Vi plus Vf. This would be really what you would call average velocity, right? So how do I find average velocity? Average velocity is just a plain sum of the two. So this is the resulting velocity vector. But now what about acceleration? What is acceleration? Well, acceleration equals v final minus v initial. So in this case, I want to subtract the two vectors. So I start with my v final, which is like this. I subtract v initial. That means I've got to take this vector and I need to flip it. So I flip it and it's going to look like this, minus vi. Always be sure to put your labels on here. And now my resultant vector, this, oops, I didn't label it, vf. So this resultant vector right here is vf minus vi, which is the same as acceleration. Okay?